I'll walk you through the Roborock Saros Z70 as if I'm on stage explaining it to a curious audience, from who made it and how it came to be, to the nuts and bolts of how it works, what it costs, and where it might take us next. The Saros Z70 is the product of Roborock, the Beijing-based robotics company founded in 2014 that has steadily evolved from making litter-mapped robot vacuums to building machines that combine advanced sensing, onboard AI, and increasingly ambitious hardware. Roborock led the project from R&D through industrial design and global release using its engineering and manufacturing teams in China. The idea for the Z70 emerged from a clear problem Roborock and other robot vacuum makers have wrestled with for years. Autonomous cleaners can navigate and clean, but everyday household clutter, socks, tissues, scattered toys, still forces human intervention. Roborock formally unveiled the Saros Z70 at the product rollouts around CES 2025, and in pre-order windows shortly afterward, presenting it as one of the first widely released consumer robot vacuums to integrate a mechanical object manipulation capability alongside vacuuming and mopping. That launch timeline and public reveal at CES 2025 are how the Z70 moved from concept to a shipped product. At its core, the Z70's headline features are straightforward but ambitious: an OmniGrip mechanical arm that can reach out, pick up small light objects, and place them or move them. Roborock's StarSight Autonomous System 2.0 for navigation and perception. Extremely high suction quoted at around 22,000 pascals, an ultra-slim chassis about 7.98 centimeters, 3.14 in tall, that lets it tuck under low furniture, a dual anti-tangle system and dual all-rubber main brushes for hair management, and a multifunction dock often called Dock 4.0 that automates emptying, mop washing and drying, and water refill management. Battery and runtime figures vary by workload and whether the arm is used, but official materials and early reviews list long runtimes in normal vacuuming modes and shorter endurance once the arm and heavy suction are factored in. These are the features Roborock emphasizes on product pages and that reviewers repeatedly call out. Structurally, the Z70 departs from the tall, litter tower look by adopting a very low-profile body that hides most sensors flush with the top and perimeter. This keeps the footprint slim for under-furniture access. Roborock advertises an Adapti-Lift chassis and Flexi-Arm riser technology that together allow the robot to manage small floor height transitions and deploy the arm only when necessary. Most consumer-grade robot vacuums, including the Z70, use molded ABS and PC-type engineering plastics for the outer shell and dock housings for durability and weight control, while internal components, motor housings, gears, arm linkage rely on reinforced plastics and some metal fasteners where strength is required. Roborock's marketing focuses on the mechanical design innovations: foldable arm, slim chassis, sealed mopping systems rather than exotic materials, and independent teardowns, and reviews confirm the use of common durable plastics and modular components. How the Saros Z70 actually works is a blend of existing robot vacuum paradigms plus some novel mechanical engineering. For locomotion and mapping, it uses Roborock's StarSight system, a combination of cameras, depth 3D sensors, and possibly time-of-flight elements depending on region model, along with traditional wheel motors and suspension that let it traverse thresholds. For perception, it fuses multiple sensor streams, optical cameras for object recognition, proximity and cliff sensors for safety, and internal odometry, then runs onboard neural networks to classify objects and plan paths. The OmniGrip arm is a compact manipulator with at least several degrees of freedom. It extends or folds out, uses a small gripper mechanism to grasp light soft items, and is driven by miniature actuators and geared motors controlled by embedded servo controllers. Actuators for wheels, brush motors, and the suction motor are standard brushless or DC motor types. Arm actuators are more specialized to provide torque at low speed. The software stack coordinates navigation, mapping plus obstacle avoidance, object recognition and decision logic, when to pick up, when to avoid, and dock routines: return, empty, wash. Reviews and Roborock materials emphasize that the arm's operation remains conservative. It works best with small, easily graspable objects and in relatively uncluttered conditions, and much of the arm intelligence is rule-based safety logic layered on top of neural recognition. Price-wise, Roborock positioned the Saros Z70 as a premium device. The official Roborock US listing has it around $1,999.99 in the official store at launch windows, while press coverage and early retail listings show some variability. Pre-orders reported prices in the ballpark of $1,899 to the $2,000 plus range, and overseas retailers have local currency pricing, for example AUD listings around $3,299 Australian dollars at certain shops. Reviewers have also summarized effective street prices and promotional bundles, which explains why you'll see a band rather than a single universal tag. If you're budget planning, expect a high-end, early adopter price bracket and occasional bundled promotions. Roborock's roots and the Z70's country of origin trace back to China. The company was founded in 2014 and is headquartered in Beijing with R&D and manufacturing operations in Shenzhen and Shanghai. The Saros series and the Z70 were developed within that company ecosystem before global rollouts. That Chinese engineering and production base is where design, firmware, and the majority of manufacturing took place. Beyond the immediate convenience of vacuuming plus occasional object pickup, Roborock and industry watchers frame the Z70's real benefit as a step toward more autonomous home robots that reduce the frequency of human intervention. Practically, that means fewer stops during a cleaning cycle to rescue a sock or move a child's toy off the path. Socially and economically, it showcases how robots can take on small, repetitive household tasks and free up time for people. More broadly, research and productization of small manipulators integrated into mobile platforms opens doors for future assistive home robots, helping older or mobility-limited people retrieve put away small items, better human-robot interaction in domestic settings, and even logistics and small package handling in constrained environments. Trend pieces from CES and Tech Press highlight that the Z70 reflects a broader industry pivot to combining perception, manipulation, and cleaning into single platforms. There are several lesser-known or hidden facts worth flagging that reviewers and teardown folks have noticed. First, the arm is intentionally limited in speed and payload. It's meant for small soft objects, not heavy lifting, and that conservatism both protects the arm and reduces safety risks but also constrains usefulness in messy, real-world homes. Several independent reviews found the arm's effectiveness uneven and sometimes slower than users expect. Second, the addition of the arm and its motors has an observable impact on battery consumption and mechanical complexity. In real-world tests, the Z70 sometimes needed more energy and maintenance attention than Roborock's simpler models: brush cleaning, detangling, occasional firmware tweaks. Third, Roborock's approach tries to keep sensitive image data local. The company historically emphasized on-device processing for mapping and object processing to limit cloud uploads, a point they have repeated across product cycles, though privacy and data policies remain something to check per region. Finally, because this is among the first mainstream consumer vacuums with a built-in manipulator, service parts, replacement grippers, and third-party accessory ecosystems are still nascent. Not everything is yet as modular or widely available as it is for older mainstream vacuums. Looking ahead, the Z70 is both a product and an experiment. We should expect iterative improvements to software, better object recognition models, improved grasp planning, smarter policies for when to leave something alone, and hardware revisions that make the arm faster, more accurate, and less power-hungry. If the concept proves popular, future models will likely refine the arm's gripper geometry, add tactile sensors or force sensors for safer grasps, improve battery capacity or energy efficiency, and integrate more sophisticated edge AI so the robot can learn household item classes over time. On a societal scale, as household robots gain basic manipulation skills, they will not only reduce small chores but could become platforms for assistive services, for medication delivery around the home, for simple fetching tasks for elderly care, or for multimodal cleaning services that combine sweeping, mopping, and item management. Industry commentary from CES and follow-up reviews positions the Z70 as an early but important step toward that future. To summarize the practical takeaway, the Roborock Saros Z70 is a China-engineered, premium robot that blends Roborock's established vacuuming and mapping tech with an integrated OmniGrip arm and a deluxe dock to push automation further into the home. It's a milestone for consumer robotics because it moves beyond navigation and cleaning into limited manipulation, but current reviews make clear the feature is nascent, impressive conceptually, useful in constrained scenarios, and likely to improve substantially with software and hardware iterations. If you're an early adopter who wants the latest in home robotics and a willingness to tolerate some quirks while the software matures, it's a compelling, and expensive, choice. If you want rock-solid, low-maintenance vacuuming today, you might weigh that against some of Roborock's simpler but proven models.